Hello guys, welcome back to Kodamigo. In today's video, we're going to learn how we can delete a node from a singly linked list. This is the fourth video on singly linked list. If you haven't watched the other videos, I have given the link of the playlist in the description box below. So if you want to know everything about setup and how you can append and search and in fact create a linked list, please watch the first 3 videos of the playlist. Now let's see how can we delete a node from a linked list. So there are going to be 3 cases. In first case, the linked list might be empty. So if the linked list is empty, then the head is pointing to null, which means that there's nothing to delete. We can print some appropriate message. In second case, there are going to be bunch of elements in the linked list, or maybe there's just one element. And the node that we want to delete happens to be the very first node of the linked list. So if let's say there's only one node in the linked list and we want to delete this, we can simply set head to null, which means there was only one node which now has been deleted. But if there are more than one node in a linked list, then we can set head to head.next. So previously head was pointing to first node, which was 45. Now the head is pointing to the second node whose data value is 123. And we can set the next pointer of the first node to null, indicating that it is now garbage collectible because there is no valid reference variable pointing to. So the memory allocated by the first node will be deallocated automatically. So now in our list there's only 2 elements because the first element has been deleted. Now let's have a look at the third case. Third case is a little bit more complicated than the first 2. So in third case, the element or the node that we want to delete either is the last node of the linked list or maybe somewhere in the middle, meaning that we have to traverse the link all the way up to the element that we want to delete, right? So let's say in this example that the node that we want to delete is the last node or the node with data value 81, right? So first thing, we're going to create another reference variable. Let's call this node, and this node, just like head, is pointing to the head node or the very first node of the linked list, right? And we have a while loop to be able to traverse through the list, and the expression of the condition in while loop is node.next. So currently node is pointing to the first node, which is 45, and node.next is 123. So which is a valid condition? The node.next is not null. That means we're going to enter into the body of while loop, and here we are checking that the element we want to delete is the next node or not. If the node.next.data happens to be the item or the node that we want to delete, then we will do the logic for deleting the node. Otherwise, we will keep moving forward in the linked list. Now, the node is pointing to the middle node, which is 123, and node.next is 81, and this is the node that we want to delete from the linked list. The node.next will point to node.next.next, which is null in this case. And now you see that the last node is not being referenced by any reference variable, so that has become garbage collectible that can be reused by some other program. Now let's implement the same logic. If you have been following along, then you must know that we have this setup. We created a class called node which has 2 things, data part and the next pointer, and here we have a class called linked list, and this linked list has a couple of methods like append, build, print and search. We have talked about these methods in our previous videos, so if you want to know about these methods, then go ahead and watch the other video, the previous videos in the playlist. I have given the link in the description box below. So now let's go ahead. Let me start off by defining a new method called delete. Alright, so I have this delete method, and this delete method going to accept only one parameter, that's going to be the item that we want to delete from the linked list. And just like many other methods that we have created within this linked list class, the delete method is also going to return this. So this is a reference variable pointing to this class itself, right? So first of all, let me return this, and here's the first case. In first case, the head is pointing to null, which means the link is empty, and in this case we are not supposed to do anything except returning this and printing out some appropriate message. So here is the second condition where the head is not pointing to null, which means that there is at least one element in the linked list, and if the element or the node that we want to delete happens to be the first node, right? So this dot head dot data is equal to the item that we are after, then we're going to delete the very first node from the linked list. Now here we have another condition. Here we are checking if the head.next is pointing to null, which means that there's only one node in the linked list. If that is the case, then this has become even more easier for us, because now all we need to do, we need to set this dot head to null and return this. But what if there are other nodes in the linked list? So first of all, we're going to create another reference variable. I'm calling it temp. This temp is pointing to the head. So now there are two reference variables pointing to the head node, or the very first node of the linked list. So now let's move on, and I'm saying that I'm pointing the head to head.next, and here at the next line I'm saying temp.next is null. So now temp is isolated. There's no reference variable pointing to it. Now this has become garbage collectible. Finally, I'm just returning this to make this delete method chainable. Now let's talk about the last condition. So here's the else condition pointing to the last node, meaning that we are supposed to traverse a list, because the node that we want to delete is either the last node of the linked list or exists somewhere in the middle of the linked list. We do not know. We have to find that out. I'm going to create one auxiliary reference variable, and this time I'm calling it node. Now node and head are pointing to the very first node of the linked list. Next, I have a loop, right? We talked about this node.next while explaining the deletion process through animation, right? So node.next, as long as node.next is not null, we're going to enter into the while loop. So here's the thing. If the node.next data matches the item that we want to delete, then we're going to create another temp variable, and that temp variable is going to point to node.next, and node.next is set to node.next.next, and finally temp.next is point to null. So that temp is now isolated, and we're returning this. That means we have just deleted a node, right? Otherwise, if we did not find the item, we need to continue searching. We need to keep moving. So we are setting node to node.next. Now let's come here at the bottom of the program. Now let me try to delete a node. I know that the node is empty. So what we can do is first of all, I'm printing the linked list, and then I'm deleting a node. I know that the linked list is empty, so there's no point of deleting this. What would happen if I go ahead and run this program? So list is empty, and when I call the delete method, it's saying that list is also empty. So this console.log statement was printed out. So if the head is pointing to null, this condition is working, right? And it is returning this, meaning that delete method is chainable. So now let me go ahead and add a couple of elements in the list. I'm going to use append method, right, to add a node in the linked list. Let me put it down here. Let me save this and clear the output. Let me go ahead and run this program. So see, there was one element, and we used the delete method to delete that. So this time we got messages like list is empty or things like that. Let's also go ahead and print the linked list. So linked list is empty. That means when there is only one element in the node, this condition is working just fine. We were able to set this dot head to null, and it deleted the node. Now let's check this condition over here. When data that we want to delete, or the node that we want to delete, is the first node, but the node is not the only node in the linked list. There are a couple of more. So let me go ahead and instead of using append, let me use build method. So we have this build method that accepts an array of items. So now I'm going to create a linked list which has 4 nodes in it. Now this method is deleting the very first node, and after deleting this very first node, the last 3 nodes should be available in the linked list. Let me remove everything here. Alright, so earlier there were 4 nodes, and when we call delete method and remove the first node is gone, and we have remaining 3 elements, right? Let me also explain how is this working. So first of all, we are creating a temp variable. So the head and temp now both pointing to the very first node. I'm setting this dot head to this dot head dot next. That means that this dot head is now pointing to second node, which is 2, right? I'm setting temp dot next to null. First node is now isolated. The head is pointing to the second node, which is 2, hence we got this output. So delete method is chainable. That means I can delete more than one element. Now let's go ahead and try deleting the last element, which is 4, right? Let me save and remove everything. Let me run this. Since the delete method is chainable, let me go ahead and try to delete the last element, right? Let me save this, click on the run button. Now you'll see that only 2 nodes are remaining. The last node, which was 4th, has been deleted. So yeah, this is all. I mean, we can keep going, and we can delete all the nodes from the list one by one. In the end, you will see that the linked list is is empty. So this is all in today's video. Thank you so much for watching this, and if you like this video, please hit the like button, and if you are new, please do not forget to subscribe to our channel before you leave, and stay tuned for more videos like this. Thank you so much for watching.
Yeah.